Welcome to another unit in the ISM exercise set Business Mathematics. This time with a unit on Extrema. Let's take a look at the exercise. Here we have calculate all possible extrema of the function f of x and y and test whether they are maxima or minima. And that's our function. So we just copy this function. And the first part, we only need the first derivatives. So here we can make it relatively easy because we only have more or less polynomials here. So the first derivative regarding to x is we take all the parts where there's an x. So the minus 2x squared plus xy squared. Derive them for x. So we get here minus 4x plus y squared. Then we do the same thing for the y parts. Here we have minus y squared plus x times y squared. Derived for y, we get minus 2y plus 2xy. This looks as follows. Then, to get our possible extrema, we set these two equations equal to 0, giving us for the first one minus 4x plus y squared equal to 0. This we can then reformulate to read as 4x being equal to y squared. And for the second one, we can do something similar. Here, first off, we set this equal to 0. And then, well, to make the second one easier, it would be a good idea if we could divide it by 2y, because then we only had an expression for x. However, before we are allowed to divide by y, we first need to assure what happens if y were 0. So we test first case, what if y is 0? Then we see from the first equation that x also will be 0. So we have one possible extremum, which would be both of the variables are 0. Then we have a second case. Here y is different from 0. And in this case, we can divide here our second equation by 2y. Then we can solve this, giving us x being equal to 1. So if we have x being equal to 1, we can insert this into our first equation. This then reads as y squared being equal to 4, giving us here two possible solutions, y being plus 2 and y being minus 2. So we see in this context we have three possible solutions. X and y 0, x being 1 and y being plus 2, and x being 1 and y being minus 2. That's our three possible extrema. Then we need to test all three of them, whether they are maxima, minima, or if neither, saddle points. And for this, we're just copying the function and the first derivatives, and we're calculating the second derivatives. For the second derivatives, that's the Hesse matrix, we take the derivative of the full vector of the first derivatives once for x, giving us the first column of the Hesse matrix, and then for y, giving us the second column of the Hesse matrix. If we take the derivatives for x, this would read minus 4, and then in the second row, plus 2y. If we work through this for the second column with y, we get 2y and then minus 2 plus 2x. So that's what our Hesse matrix would look like. And then we have to check for all three possible extrema. So we insert them here step by step. We start with 0, 0. Then we would see here our value in the upper left. So the derivative twice for x is negative, and the determinant of the Hesse matrix, minus 4 times minus 2, being 8, is positive. So this is an indicator that here we have a maximum. So we know 0, 0 is a maximum. Then we test 1, 2. Here we get in the upper left minus 4, so it's negative, but the determinant, that's minus 4 times 0 minus 4 times 4. So minus 16 is negative. So if they both are negative, this means we have a saddle point. And we're doing the same thing for 1 and minus 2. And here we get more or less the same result. The upper left value is negative. The determinant is also negative. So this means we have a saddle point as well. And this is the answer for this exercise. We have two possible extrema. However, only the extremum at 0, 0 actually is minimum or maximum. In particular, it's a maximum here. Well, this insight then concludes this exercise. And I hope you enjoyed listening to it. You learned something from this exercise. And if you want to see more of these types of exercises, feel free to visit the rest of this exercise set or take a look in the corresponding playlist. I say goodbye and see you next time.